Hello everyone. So before we start today's lecture, let me ask you if you have any doubts from the previous lecture, we can discuss them right now. Alright, so in today's lecture, we are going to discuss a few things about projectile motion. We'll start from where we left the last time. In the last lecture, we discussed what projectile is, what does projectile motion look like, what is the angle of projection, the initial speed at which a projectile is projected. In this lecture, we will discuss how much time does a projectile take to complete its motion, and that is also called the time of flight. So here is what projectile motion or a projectile's motion looks like. We have an object that is projected from the ground with an initial speed of u at an angle of projection from the horizontal as theta. In the last lecture, we discussed that the x component of its initial velocity ux is u cosine theta, while its y component is u sine theta. This is how we resolve the initial velocity vector into two components along the x as well as the y-axis. The acceleration of this particle, since it is motion under gravity, will be equal to minus 9.8 meters per second square downward. It has no acceleration in the x-axis. Do we have any doubts over here? Alright, so let's move on to the time of flight. So the time of flight is the time for which the projectile stays in the air. How do we calculate this time of flight? We can use the three equations of motion because this projectile is moving under gravity. Since it is moving under gravity, the acceleration of the projectile is always a constant, which is minus 9.8 meters per second square, minus because the acceleration is in the downward direction. Since the acceleration is constant, we will be able to use the three equations of motion. Can anyone tell me what equation of motion do we use over here? We need to find out the time of flight. So the time is only there in two of the three equations, which is the first equation as well as the second equation. Now the first equation also involves the final velocity. We do not have the final velocity of the object. The particle is going from point A to point B. We know the velocity of the particle at point A, but we do not know the velocity of the particle at point B. Therefore, we are going to use the second equation of motion. This is the second equation of motion. S is equal to ut plus half at square, where S is the displacement, u is the initial velocity. Over here, u is also the initial velocity and not the initial speed. A is the acceleration while t is time. All of these quantities are vectors, so remember to put them with sign. Now this equation is always used in one particular direction from an initial to a final point. Let us use this equation from A to B, which is the initial and the final point, and let's use this equation in the y direction to find out the time of flight. Once we convert this equation in the y direction, we will have Sy, which is the displacement in the y direction, is equal to Uy, which is the initial velocity in the y direction, times t plus half Ay, which is the acceleration in the y direction, times t square. Now the displacement from A to B in the y direction is 0, because when the particle goes from A to B, it only displaces itself to the right and not up or down. Therefore, the displacement in the y direction is 0, which is equal to initial velocity in the y direction. We have already done that last time, which is u sine theta. The t is time of flight over here. As the particle goes from A to B, it takes the complete time, that is, it is in air. So t is time of flight plus half. Acceleration in the y direction we can see here is minus g, minus because it is downward, and t square, which is time of flight square. We are asking this equation, when is the displacement in the y direction for this particle 0? That is what we ask. It is giving you two answers. One of the time is 0, while the other time we can see it's 2u sine theta divided by g. So you ask a question, when is the displacement in the y direction 0? It says the displacement in the y direction is 0 at time equal to 0, which is true. The particle is still at A, it is time equal to 0, and the displacement at y direction is also 0. The second time the displacement in the y direction is 0 is when the particle reaches B again, because throughout A to B, the displacement in the y direction is positive, while as it reaches B, the displacement in the y direction again becomes 0. That time is 2u sine theta by g, and this is also called the time of flight. If we want to find the time of flight in such a motion which is a ground-to-ground projectile, we can always use this particular equation. Let us take an example. Let's say that the initial speed of projection is 10 meters per second and the angle at which it is projected is 30 degrees. So to calculate the time of flight, we use the equation 2u sine theta divided by g, which is 2 times of 10 times sine 30, which is half, divided by 9.8. So we get 10 divided by 9.8, which is approximately 1.02 seconds. Since all the quantities are in SI units, the time is also in SI unit, which is seconds. So this is how we solve for time of flight for any general example. So now let us try another example. It's right over here. A football is kicked with a velocity of 20 meters per second at an angle of 45 degrees with the horizontal. The first part says find the time taken by the ball to strike the ground. Let's try and attempt this problem. So let us note down what the given data in this problem is. The initial speed is given to you as 20 meters per second, this is u, and the angle of projection is given as 45 degrees, which is theta. Over here, time of flight is equal to 2u sine theta by g. When we input all the values, we get 2 times of 20 times sine of 45 divided by 10. Over here, g is given to you as 10, which gives you 2.83 seconds. I hope this was clear. In the next lecture, we will analyze what maximum height and horizontal range mean. So maximum height in the diagram can be represented by the maximum height the projectile reaches in its motion. This is also represented by the letter h, and the horizontal range is given by the distance between A and point B. This is the horizontal distance, that is, at what point does the object reach from A on the ground again. So let us look at a simulation over here. Now this is a sort of projectile we are talking about. Let us project a cannonball from a cannon at an angle of 50 degrees with initial speed of 16 meters per second. When we fire this projectile reaches a certain point on the ground. So it has reached approximately 25.8 meters from the initial point of projection. That is your horizontal range. When we talk about the time, it took 2.5 seconds to reach this point. Therefore, the time of flight is 2.5 seconds. The range is 25.7 and the height at this instant is 0. You can check out the height at any instant, 6.17 meters over here. When we talk about the maximum height, that is 7.66 meters. The range at this instant is 12.85 meters, which is approximately half of the maximum range. The time is 1.25 seconds, which is approximately half of the maximum time. Over here, it was 2.5 seconds. So these are the three quantities: maximum height, time of flight, and the horizontal range. We have already calculated the time of flight. In the next lecture, we will look at the horizontal range as well as the maximum height. You can change the angle of projectile and project it at different speeds, and we can check out the maximum range, the maximum height, and the time of flight for all these projectiles. Do we have any questions from this lecture? Alright, so a homework assignment will be assigned to you. It has 10 questions and we will discuss them the next time.